Screen ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ?
ಕಾಣಿಸ್ತಿದೆ sir.
Okay, fine. So today we will solve the one numerical on Otto cycle. So Otto cycle is also called as constant volume cycle because the combustion takes place at constant volume. Okay, and we need to understand the four processes to calculate some unknown values. Process 1 to 2 always compression. What type of compression? Isentropic compression. So during which S1 is equal to S2. Okay, and you are new to these thermodynamics course, and some equations you need to remember. Okay, later you will understand why that equation has come, how it has derived. Okay, do not worry. Now just to remember the equation, that's it. So process 1 to 2, I will apply this equation. PV to the power of gamma or n gamma is equal to constant. This is the equation I will apply for isentropic process always. Okay, the second process is isochoric, or it is also called as constant volume heat addition. Here is a heat added. 2 to 3 process. Heat supplied or heat added, both are same. So 1 to 2 is isentropic. Process 3 to 4 isentropic expansion. Here is the expansion. So for expansion as well as for compression, the third and the first process, I will be applying this equation. PV to the power of gamma is equal to constant. This gamma is value is 1.4 for air. Remember, if this value is not given in the numerical given data, you need to take it as 1.4. And the last four process is constant volume heat rejection. The heat is going outside, that I have taken as QR notation. And similarly, the TS diagram is we have plotted. So dear student, just you observe these four cylinders, 1, 2, 3, 4. And here I have clearly mentioned that the beginning of the process, that is compression, starts from BDC and it will end at TDC. These two are dead centers. So between these 2 points, the piston, this piston will move up and down. So when the compression starts, point number 1 is beginning point. Keep in mind, point 1 is beginning of compression and point 2 is end of compression. So this dotted line represents once the compression process complete, this is the position of the piston. So 1 to 2. And during 2 to 3, the piston is not moving. It is at constant volume. It is not moving from TDC to BDC. See here, the position of 2 and the position of 3 both are at same place. 2 and 3 both are same. So it is called as constant volume cycle. And they may ask you in the exam or interview, constant volume, that is combustion, heat addition takes place at clearance volume. This volume, I will call it as clearance volume. Here, the difference between cylinder head and the piston head in TDC, it is called clearance volume. And next process during 3 to 4, from 3 to 4 process, the expansion process, the piston will move slowly towards BDC. So once expansion completes, this is the position. And 4 to 1, the fourth process, again heat rejection. During heat rejection, volume will not change. And dear students, I am asking you, I am telling you again and again, volume means volume of the gas inside will not change. Okay, same volume will be considered. When we will consider the same volume? When the piston is not moving, of course, the volume will be remain same. For example, you take a balloon. Okay, until unless you press the balloon, the volume of the balloon will be remain same position. It will not change. When you apply some force in the horizontal direction or vertical direction or in the lateral direction, then the size of the balloon may decrease. Until unless there is no displacement of the balloon, the volume of the gas will not change. Okay, similarly. So next we will take one numerical. Okay, I hope you have a calculator with you, so that we can finish it up easily. Solution: a 4-stroke SI engine. SI means spark ignition engine. Keep in mind, it is spark ignition engine. So petrol engine is called spark ignition engine, If it is diesel engine, we will call it as compression ignition engine, that is CI engine. Okay, CI engine is also called diesel engine, and the spark ignition is petrol engine. Next point. So petrol engine works on which cycle? Otto cycle. In the Otto cycle, heat, that is combustion, heat addition, heat supplied at constant volume. So they may give any one value in the exam. Out of three, they will give. Here is a fourth one. One of second of name, third name, fourth name. There are four different names. Out of four, they may give any one, or for understanding student purpose, they may give two also. Has the compression ratio 6. So compression ratio will be represented with this letter R, right? R is equal to 6. So if you write R, I will suffix C, I will write, because it clearly indicates that C stands for compression, R for ratio. So compression ratio. This is equal to total volume, that is clearance volume plus stroke volume divided by clearance volume. Okay, this is the formula we have discussed in the previous video lecture. Compression ratio is defined as the ratio of total volume. Total volume is sum of clearance volume plus swept volume, and the ratio of clearance volume. Keep in mind. And swept volume 0.15. Swept volume, out of these two, clearance volume and VS, which one is swept volume? VC or VS? So VS is swept volume. Okay, it is also called as clearance volume. Sorry, stroke volume. Okay, stroke volume or it is also called as one minute. Stroke volume, or it is also called, what he has given?
Swept volume.
Swept volume. So S stands for stroke, S stands for swept. Please remember this equation. Anyway, this data is given directly. If this value is not given directly, you may use this formula, pi by 4 d square into L. L is stroke length, this value will be given, and d is the diameter of the cylinder. If diameter and length is given, you need to calculate stroke volume or swept volume. But anyway, in this numerical, he has given direct value, so you need to calculate using any other formula. Next, pressure and temperature.
Length of the stroke kodtara sir.
Sorry. Yes.
Length of the stroke.
Yeah, length of the stroke will be given 100%. 100% it will be given, because these diameter as well as length are design properties. Someone has designed that engine. Unless he mentioned geometric properties, that is design properties, we cannot do any calculation. Okay, volume, clearance volume he must be given, swept volume he must give, or else he will give VS and he will give total volume, but he will not give clearance volume, because, and you need to calculate VT means total volume is equal to VC plus VS. This value will be given in the numerical. Sometimes for confusing the students, he will give total volume but not clearance volume, and he will give stroke volume. Or if the stroke volume is not given directly, use the diameter and length. So we know this value, and we can calculate VC. Okay, there are such numericals also there. We will discuss later. Understood?
Yes.
Yeah, next line, it is important now. Pressure and temperature at the beginning of compression are 98 kilopascal. So now, my dear students, now time has come to draw one PV diagram of Otto cycle, pressure versus volume. So 1 to 2 is isentropic compression, that is constant entropy. Here is 0.2, here is 0.1. The second process is constant volume combustion process, 0.2 to 3. And the third process is isentropic expansion, 3 to 4. Okay, you have to remember all these processes. You practice, so it will become easy. Okay, do not worry. So 2 to 3 is heat supplied, and 4 to 1 is heat rejected. Now what he has given, my dear students, Pressure and temperature at the beginning of compression is 98 kilopascal. In this cycle, P is pressure on the y-axis, V is volume. So pressure is P1 here. Point number 1 is what? It is beginning of the compression or end of compression. Point number 1. This is BDC and point number 2, it is TDC. Which point is beginning of the compression here? Cycle starts at which point? Here I have told you on the previous slide. Here it is there. Point number 1 is at BDC. The piston is moving from BDC to TDC. Which stroke it is? And the gases are compressed. What is the name of the process they have written here? So isentropic compression. So point number 1 is beginning of compression. Okay, I think you have not seen the previous video lectures. Okay, please go through all those video classes and all so that you will understand the numericals easily. Otherwise, you will be on the same boat. You will not understand the numericals clearly. So P1 is beginning of compression. Pressure is beginning of the compression. That I will write P1 is equal to 98 kilopascal. So here term kilo is there. You remove the kilo. What you need to do to remove kilo and write in terms of Pascal? What you need to do? (98) into 10 to the power of 3 Newton per meter square. To convert kilopascal to Pascal, 98 into 10 to the power of 3 Newton per meter square. Next line, what he has given? And temperature at beginning of the compression, same temperature is also given, that is T1. Temperature is represented with T1, no? So T1, here the temperature is given. Look at this value. Here is compression, temperature and pressure. Both it is given. So T1 is equal to 60 degrees Celsius. So convert to Kelvin. 60 plus 273. How much you will get? 333 Kelvin. Okay. Is it right or wrong? 60 plus 273. So determine pressure and volume and temperature at all the points. All the points is we need to calculate P2, we need to calculate T2, and as well as P3 and T3, and as well as P4 and T4 is equal to how much? This is all these 4 points and 4 unknowns we need to calculate at all the points, temperature and pressure. And also he is asked to calculate, also find work done. He is asking to calculate the work done and efficiency of the cycle. Okay, let me write. The work done is represented with W. Work done is equal to heat supplied minus heat rejected. This value you need to calculate. And efficiency also you need to calculate. What is the efficiency formula? 1 minus 1 by R to the power of gamma minus 1. So this is the value, efficiency equation, and this is the equations. So this is solution. Step number 1 is a given data you have written. Next go to step number 2. Step 2. Okay. So efficiency you have calculated using this equation, this simple equation. Now we need to calculate heat supplied and heat rejected. Heat supplied is QS. QS is equal to And dear students, you need to understand this equation. Heat supplied is at constant volume and as well as heat rejected is also at constant volume. So what is the equation? Basic equation mCp delta T. Delta T is nothing but difference in temperature between second and fourth process. T3 minus T2, and mass is always assume it as 1 kg because he has not given anything in the numerical. So let us take it as 1 kg. And Cp value and Cv. Cp stands for specific heat at constant pressure. This value Cp is given and as well as Cv also is given in the numerical. Okay. So Cp is how much he has given? 1 kilojoule. So 1 kilojoule means 1000. So that value I will substitute here. Okay, so the M value is 1, Cp value is 1000 because Cp is nothing but he has given 1 kilojoule per kg Kelvin. 1 kilojoule means 1000. 1 into 10 to the power of 3. Okay, how much is the value of T3? We don't know. We need to calculate, and as well as T2. T2 is also we don't know. So to calculate heat supplied and heat rejected, we need to calculate all four temperatures first. So to calculate that all four temperatures, you need to remember one basic equation, my dear friends. Remember T2 by T1 is equal to V1 by V2 to the power of gamma minus 1. This is the value you need to remember. Okay, this is the equation. How this equation has come, we will discuss later. In one of the video lectures, I have explained clearly how this equation is derived. But time being, you just by heart or remember this equation. T2 by T1 is equal to V1 by V2 to the power of gamma minus 1. And here, which values is given, which value is not given, you need to identify. And here, which value is given? T1 is given. So using this equation, I can write T2 is equal to T1 V1 by V2 to the power of gamma minus 1. T1 is how much? 333. And V1 is not given directly, but he has given indirectly the value of Vc and the value of Vs, because point number 1 is total volume. So total volume Vt is equal to Vc plus Vs. So substitute Vc as 0. How much he has given clearance volume? Has he given clearance volume? No, he has not given clearance volume, but you need to calculate. How will you calculate using clearance volume and stroke volume? Okay, this equation he has given. One more equation, you know. Compression ratio is equal to 6 Vc plus Vs. Okay. So tell me, how will you get this value? Sorry?
Network issue ಆಗಿತ್ತು ಅದಕ್ಕೋಸ್ಕರ
Okay, fine, no issues. Can you see the screen? Okay. What is V1 in the given PV diagram? V1 is total volume. Total volume he has not given directly. Total volume is sum of clearance volume and stroke volume. Out of these two, I will write here. So let me erase it. Okay, the total volume is equal to Vc plus Vs divided by, this is the total volume. Okay, and compression ratio is what? Vc plus Vs divided by Vc. This value is he has given as 6, but Vc is not given. Vc value is not given. So how to calculate Vc using this equation? You tell me, how will you calculate? So you simplify, my dear students. This is easy, no? Vc by Vc plus Vs by Vc. Vc will get cancelled. You will get 1 plus Vs by Vc. Okay. So I will write here 1 plus Vs by Vc. 6 is equal to 1 plus how much is the value of Vs? It is given in the numerical. Vs is 0.15. That you substitute here. 0.15. And Vc, right, as 6 minus 1, 5. 5 is equal to 0.15 divided by Vc. So Vc is equal to 0.15 divided by 5. So how much will be the answer? 0.15 divided by 5. So we'll get 0.03 meter cube. This will be the value. So that value is substitute in the above equation, that is Vt, total volume. Total volume V1 is equal to Vc plus Vs. Okay, so V1 is equal to Vc is 0.03 plus 0.15 is a stroke volume. Stroke volume or swept volume he has given as 0.15. And keep in mind the value of Vc should be less. Vc is less here. It is only small value compared to Vs. So value of Vc should be less than Vs. So how much I will get it as 0.18 meter cube. So T2 is equal to T1 into total volume divided by V2. V2 is what? Clearance volume. V2 is equal to clearance volume. Why it is clearance volume? Look at the board. Here, point number 2. So point number 2, here it is V2. Up to here it is V2. Here it is V2. V2, V2, V2. V2 is equal to V3. Both are same. So that I will write V2 is equal to Vc. Substitute how much is the value of T1? 333. V1 is 0.18. Vc is how much? We got 0.03 to the power of gamma minus 1. Gamma is 1.4 minus 1. So we'll get the value of T2. Calculate and tell me the value of T2. So I am getting at 681 Kelvin. Okay. So T1 you have calculated. T1 is given in the numerical. Using T1 you have calculated T2. Now you need to calculate T3. T3 you need to calculate. Is there any data is given related to T3? Yes, one more data is given. Okay. Look at this data. What he has given. If the heat supplied to it is 150 kilojoule per kg, means heat supplied, QS value is given. QS value is given here. Heat supplied to it means is to the cycle. To the cycle is 150 kilojoule per kg. Okay, per kg means mass is equal to 1. Okay, so here is the equation. This value of QS is 150. So 150 is equal to 1000 into T3 minus T2. So using this equation, equation number 1, I can calculate the value of T3 because QS is how much? 150 into 10 power of 3. Heat added to the system is positive. Heat rejected by the system is negative. So QS is equal to 1000 into T3 minus T2. Simplify this equation, 150 into 10 power of 3. Why I am writing this equation? Because this is value is given in the numerical. So 1000, T3 is unknown. How much is a T2? 682. So 1000 get cancelled. So T2 is equal to
681 ಇದೆ sir.
Sorry?
T2 is 681.
So yes, 681. Yes, correct. 681. And 150 plus 681. How much is that? 831 Kelvin. If you have calculator with you, and calculate. T2 is, sorry, T2 or T3? This is T3. T3. Okay, now T1 you have calculated, T2 also you have calculated, and T3 also you have calculated. Now your aim is to find the value of T4. Okay, so using the same equation what we have written on the board here, this equation I have written for compression. Okay, same equation, similar equation you need to write for expansion. So expansion is T3 by T4. Okay, so I will write here T3 by T4 is equal to V4 by V3 to the power of gamma minus 1. And dear students, I will give one hint. What is that hint is, in the numerator if you have taken T3, in the denominator you take volume on the right hand side, reciprocal. Okay, in the denominator you have taken T4, in the numerator on the right hand side you take V4. Same equation with your permission can I write like this, T4 by T3 is equal to V3 by V4 to the power of gamma minus 1. We can write the same equation, we will get the same answers. Okay, so T3 by T4. So using this equation we calculate T4 because already T3 is known. What is V4? V4, point number 4, volume at point number 4. Volume at point number 4 is same as volume at point number 1 because it is at constant volume heat rejection. So V1 is equal to V4. V1 is what? Total volume. So total volume we can write it as V1 as well as V4 or as well as VT. VT means total volume. So I will write, where is the value of V1? Somewhere you have calculated, total volume you have calculated. Yes, here we have calculated 0.18. V1 is total volume or sum of clearance and stroke volume. So same, so I will take V4 is equal to V1 is equal to total volume, that is 0.18 meter cube. 18 meter cube or what? Yes, 0.18 meter cube. And V3, we need to calculate V3. What is V3, my dear student? Again, go back to the PV diagram. Okay, V3 is here. Point number 3 is here. Point number 3 and point number 2 both are on the same. Sorry. Yes, V2 is equal to V3 and it is equal to Vc, clearance volume, and clearance volume is given in the numerical. V3 is equal to V2 and is equal to Vc. This is 0.03 meter cube. Okay, that I will substitute here, T3 by T4. Okay, anyway, T3 is already calculated in the previous step. Directly you substitute. Why you are again writing the equation? Let me substitute. What is T3? 831. Substitute as 831. (831) divided by T4 is unknown. How much is V4? V4 is equal to V1 is equal to 0.18 divided by Vc is 0.03 to the power of 0.4. Why it is 0.4? Gamma is 1.4 minus 1. It is directly 0.4. I will return. So T4 is the only unknown. So 0.18, 0.03 to the power of 0.4. So 831 divided by this answer. So I am getting it as T4 as I am getting 405. 5.8 Kelvin. Okay, so all four temperatures you have calculated now. T1 anyway he has given in the numerical. You have calculated T2, you have calculated T3, and also you have calculated T4. And efficiency also you have calculated. Efficiency already we have calculated in the step number 2 directly using compression ratio. And he has asked pressure at all the points. P1 is given and he is asked to calculate P2, P3, P4. How much is the value of P1? 98 kilopascal. Here it is highlighted with the green color. 98 kilopascal. Here is a value 98 kilopascal. Try to see the value 98 kilopascal. That is P1 value. So now I will calculate P2, P3 and P4. P1 is, write the values. P1 is how much? 98 kilopascal. So 98 into 10 to the power of 3 Newton per meter square. Now you need to calculate P2 and as well as P3 and as well as P4. What values we know? T2, T3, T4. And also I know V1. V1 is equal to V2 is equal to Vc. Also I know V4. V4 and V1 is equal to total volume. This should be equal to V3. How much is this value? 0.03. How much is this value? 0.18 meter cube. This also. These are the 4 values I know. T2 also I know. T3 also I know. T4 also I know. And I'm trying to calculate using P1. I'm trying to calculate P2. Dear students, you remember the best one equation is PV to the power of gamma is equal to constant. You apply this equation at point 1. How will you write? Point 1, V1 to the power of gamma is equal to constant. Same equation if you write point 2, P2, V2 to the power of gamma. So using the first term and the second term, I can calculate the unknown. Okay, so P1 is known value. I don't know P2. So take on the left hand side, P1, V1 by V2 to the power of gamma. How much is a P1? 98. Write down the values. 98 into 10 to the power of 3. How much is V1? V1 is 0.18. How much is V2? 0.03. Gamma value is 1.4. So calculate P2. 0.18 0.03 to the power of 1.4 into 98,000. So I am getting it as 1, 2.
Sir, 1.204 into 10 to the power of 6.
Okay, 1.204 into 10 to the power of 6. Okay, Newton per meter square. Very good, correct answer. Okay, now calculate P3. Okay, I will highlight these answers, these equations. Please remember this equation. Okay, don't worry. After solving 1 or 2 or 3 problems with your own, you can understand all the equations. Not to worry. This is the first numerical you are solving. You may face a little bit difficult. Not to worry. Don't get depressed. Okay. Next, I need P3. I know P2. I know P2. I know P1. I know T1 also. So using P1 and P2 and T1 and T2, I need to calculate P3. Okay. What is the basic equation is, my dear students, the second process is constant volume process. Constant volume process. What is ideal gas equation? PV is equal to MRT. M and R are same. For the given gas, M is equal to 1, R is equal to 1. So using this, I will write PV by T is equal to some constant value. M is also some constant. It is not 0, some constant. 1 into R value is also some 8314. You will get some constant. Now try to write this equation at point 2. So P2, V2 divided by T2. Same equation I will write at point 3. P3, V3 by T3 is equal to some constant. Right hand side is the same value. So obviously left hand side will be same. So P2, V2 divided by T2. P3, V3 divided by T3. And here, if you observe carefully, some terms get cancelled. Which terms get cancelled? In the second process, constant volume, that is point number 2. Point number 3 is at constant volume, that is 2 and 3. V2 is equal to V3. Second process. So V2 and V3 both get cancelled. So only unknown is P3. So write down the equation for P3. P3 is equal to P2 T3 divided by T2. Just I am simplifying mathematical equations, basic mathematical equations you use and write an expression for P3. So P3 is equal to P2, how much you have told? One student has told 1.204 into 10 to the power of 6. Very good. T3. T3 is already we have calculated in the previous page. How much is a T3? Yes, 831 here. So that value you substitute here. T3 is 831 divided by T2. T2 also we have calculated in the previous first two pages. T2 is 681. Ash has told 681. Okay, I will write 681. So simplify this equation and you put all the values in the calculator and tell me the value.
For 1.469 into 10 to the power of 6.
Yes, 1.46 into 10 to the power of 6 Newton per meter square. And dear students, whether these calculated values are correct or wrong, how to identify? So due to some calculator mistake, you may get some value, wrong value sometimes. Okay, 1.46, whether it is right or wrong. 1.2, whether it is right or wrong. So how to cross check? Just go back to PV diagram. So in the PV diagram, point number 1 is here. This value is 98. Point number 2 is here. And y-axis is P2. P2 should be more than P1. You should get more than, not even one more digit, because there is a lot of gap between P1 and P2. So P2 should be more than P1, and as well as comparing point 2 and 3, P3 is more, it is higher. So P3 should be more than P2. So cross check now our values, what we have calculated the P3 and P2, whether that satisfy the condition or not. P2 is 1.2, it is more than 98 degrees, 98 into 10 to the power of 5 Newton per, 9 power of 3 Newton per meter square. Correct, it is satisfied. This value is highest than 0.1. P3 is 1.46. Yes, it is also highest. 1.2 is less than 1.4. So P3 is more. So our condition is satisfied. So whatever the answers you are told, it is correct. That is how you need to cross check your answers. Now P4 we need to calculate. So to calculate P4, again I will use the 3 to 4 process. 3 to 4 is isentropic expansion. 3 to 4. 3 to 4 is isentropic expansion. What is the equation I will use? A simple equation is there. P V to the power of gamma is equal to constant. So this equation you write at point 3. P3 V3 is equal to constant. Same equation you write at point 4. P4 V4 to the power of gamma is equal to constant. On the right hand side you have some constant value. So obviously left hand side will be equal to each other. So P3 V3 to the power of gamma, P4 V4 to the power of gamma. Now your aim is to calculate P4. So P4 you take on the left hand side and simplify the equation. Okay, now cross check V3 and V4. On the previous page on the top you have written here what is V3, what is V4. Here V3 is equal to V2, that is equal to clearance volume, so 0.03, and V4 is equal to V1, that is 0.18. So I will substitute with PV values also. 1.46 into 10 to the power of 6. V3 value is 0.03. V4 is 0.15 to the power of 1.4. So how much will you get? So simplify. So I am getting it as 1.54 into 10 power of 5. I hope you will also get the same answer. P4 is equal to 1.54 into 10 to the power of 5 Newton per meter square. Okay, these are the values. So you have calculated P1, P2, P3,
Yeah,
P4.
1 by 3.
Same answer you are getting or different answer, Dhanush?
It's great, sir, but 0.1 is difference, that's it.
0.1 no, doesn't matter. Okay, so small difference is okay. So now we will make it split step. Okay, this is step, assume it is step number 2. Step number 2 is efficiency. Step number 3 is you take from this side. Step number 3, QS is equal to heat supplied. So this you take step number 4. Calculating temperatures you take step number 4, and calculating pressures you take step number 5. Here it is step number 5. So first step number 5 is here P1, P2 you have calculated. Where you have calculated P3? Yes, P3 you have calculated. So last you take step number 6. Okay, so these are the calculations. Do you have any doubt? You can ask me.